Alright, good afternoon everyone. I am Brody from the VEXU team AAMU1, and today we're going to be doing our second stream for CAD design, mainly in Onshape, for VEX pushback. And real quick, we're just going to start off the stream by talking about the ruling from, a message, as the title suggests, a message from the VEX Robotics Game Design Committee. And this is the forum post that the Game Design Committee made in response to the petition that the VEX community had in order to get the plastics rule, or custom plastics rules, changed to how they were in previous seasons. So real quick, if you are unfamiliar with the situation, it was because VEX, in the current season, they have updated the rules for the, for the use of custom plastics. For example, here in R25, that is the main, let's see, what was it? General rules, I think, or no, I think it was robot rules. But it's, I'll just do Control F, R25. Oh no, 2, 5. Yeah, so let's go here, R25. So yeah, R25, of course, has been revised from, instead of teams being able to just use a 12-inch by 24-inch sheet of custom plastic, now it has been revised to 12 pieces total, and each piece can be no larger than 4 inches by 8 inches. Excuse me. Right here, part B, each individual piece of non-shattering plastic cannot be larger than 4 inches by 8 inches, or basically 32 square inches by the overall width of 0.070. So there was a petition, of course, to get this rule revised to be like the previous seasons, to where, it's a 12-inch by 24-inch total piece instead of split pieces like this. Now, I think we're just going to straight up read this verbatim because it's not too terribly long, maybe like a 2-3 minute read. But this is something that we'll go through just to clarify what the GDC's ruling is on the specific issue. Alright. So to start, the GDC starts by saying, to the VEX V5RC community, we have seen your concern, heard your feedback, and would like to take the opportunity to explain the thought process and reasoning behind some of the changes to the robot construction rules for the 2025-2026 VEX V5 robotics competition season. Most of the concerns seem centered around the following topics: R25, the custom plastics allocation, 3D printed decorations, and license plates. So they, of course, here they break it down by section for the custom plastics, 3D printed decorations, and license plates. So we'll mainly just focus, of course, on this first section being custom plastics. Alright, so over the last 3 seasons, we've noticed a shift in how teams interpret the previous rule for custom plastics. Teams began to push the limits of the rule, constructing incredible mechanisms and robots with innovative uses of non-shattering plastic. This trend was most noticeable at the highest levels of competition throughout this past season. Teams used hundreds of custom plastic parts on their robot. This revolution created a skill gap that we believe is not within the ethos of the VEX V5 robotics competition, and we became concerned that it may have gone too far. The VEX V5 robotics competition, V5RC, at its core is a closed system robotics competition intended to provide teams with a relatively level playing field. For the most part, every team competing in V5RC has equal access to all the same parts. It is the GDC's opinion that custom plastic, to the extent that it was used in the 2024-2025 season, was antithetical to the closed system architecture that V5RC relies upon. We identified this as a necessary update to bring the competition back within its intended bounds. We also received feedback from referees and event partners throughout the year expressing concerns that the extensive use of custom plastic parts made inspection virtually impossible at some events. Event staff were having trouble identifying parts as functional or non-functional and could not identify a way to accurately verify that all custom plastic parts on a robot were nestable within a 12 by 24 inch sheet of plastic. It was reported that in the interest of time, in some regions this rule was all but ignored during inspection. In other words, the previous custom plastics allocation rule was unenforceable. While we did set clear limits this year, 12 plastic pieces up to 4 inches by 8 inches each, it's worth pointing out that this actually allows more total material than before. In the 2024-2025 season, high stakes, teams were limited to a single sheet of plastic up to 12 by 24 inches. That's 288 square inches. With the new R25, teams now have 384 square inches of plastic to work with. That's over 30% more total area than before. So while the size of each piece may be smaller than some previously legal parts, the total allowance is actually larger. We feel that this is an appropriate compromise. So real quickly, I'm going to give my thoughts on this. I actually, unlike many in the community, I actually have to agree with the game design committee this year. Especially considering the fact that there's not much of an advantage in terms of like weight on a robot. And while yes, a lighter robot can get up to speed faster, this year there's not like a obvious advantage to your robot being lighter, given the fact that there is not a lifting element to this year's game. And so that's one thing that I think people should take into account, is that how much plastic do you really have to use this year? Because really the allocation is fair. Like, for example, it makes it clearer, easier to do inspection, because I definitely know that when I've done an inspection in the past for competitions, it was hard to determine if all the pieces for a robot that were cut out could actually fit within the allocation. And so I can definitely see why the GDC is wanting to clarify that a little bit more, and so fair on them. And for VEXU teams like this, this of course does not apply really to VEXU, because VEXU has different rules as far as materials go. Teams could really use whatever plastic or however much raw material as it's defined in the game manual. And for like any machining or anything, teams basically just have to prove that they were the ones that machined it for the holes and everything, which is basically the same for the engineering notebook for like V5RC, and proving that you like built the robot and stuff like that. So not much of a difference. Alright, so now moving on to 3D printed decorations. This one I can kind of understand, because there's a couple times to where it was hard to tell if a 3D printed part was purely decorational and non-functional, but now they're just completely removing it, as we'll get into. Similar to the confusion with plastics, event staff around the globe have had an incredibly difficult time determining whether or not 3D printed parts are truly non-functional to a robot. In hindsight, the use of the term non-functional was not fair to our volunteers. We were asking them to determine if a part of a robot they have never seen before serves a game-affecting function on the robot without even watching a match. This unfortunately led to varied interpretations, with some legal parts being removed at the time, and some illegal parts being allowed to pass at the time. It was determined that the cleanest solution to this issue was to not allow any 3D printed parts on robots, no matter their function or lack thereof. This should make it much easier to determine legality of parts on robots, allow for more efficient inspection, and create a healthier competitive environment that better fits the closed system that VEX intends to be. We encourage teams to find other ways to use 3D printers to serve their needs, adding paddles to controllers, creating custom toolbox inserts, and other organizational tools, and making autonomous alignment jigs are all good examples of using 3D printing in VEX. I would definitely say like the autonomous alignment jigs them specifically saying that those are legal for you to make out of 3D printing, like for you to make a model to make your alignment more precise. I would definitely say that that is a good thing as well, because now you don't have to completely construct one yourself if you do have a super precise autonomous. Alright, so now moving on to license plates. This one, I don't understand quite why people are getting kind of up in a tizzy about. Because the license plates, it's just a name badge for your robot, essentially. And so I guess that I might need to dig into it a little bit more to figure out why people aren't so happy with this ruling. But anyways, moving on to what the GDC said. We updated the license plate rules for the 2025-2026 license plate rules for 2025 to 2026 to help observers, referees, MCs, inspectors, and teams. License plates help observers identify what team and alliance a robot belongs to. Referees rely on license plate colors and legibility to make rule calls like holding. MCs depend on license plates for accurate in-match commentary. When a license plate falls off during a match, team and alliance information becomes lost and everyone's experience suffers as a result. Limiting each robot to a single color of license plate and encouraging stronger mounting methods will help ensure that the correct plates remain visible throughout the match. Given the importance of license plates in these situations, we felt that it was appropriate to reconsider their status as non-functional as well. Until now, license plates have been considered non-functional decorations, but this status hasn't been consistently enforced. Classifying them as functional components eliminates the need for judgment calls about functionality, e.g., or for example, did contacting the high-stakes ladder with a license plate meet the AWP criterion, and makes them another part of the robot. I definitely agree with the GDC here that license plates should be considered a functional part because you cannot compete without them. So I'm not sure why they considered them. Like, I could see them being decorations, but considering them non-functional and not serving a function when they're required and they are basically the name badge, like I said, for your robot, they do serve a function as they clarify, in referees, onlookers, scorekeepers, inspectors. Like, they serve a function that is necessary to the proper function and completion of a competition. And so why they were considered non-functional for so long, I do not know, but I'm glad that they rectified it, and I'm hoping that this rule actually stays for the rest of VEXU competitions. I will say this though, I would appreciate them saying, okay, you can have your two like VEX license plates or whatever, license plates to follow the rules, but you can also have, like, for example, a third license plate on your robot that could be, for example, non-compliant and a decoration, or like non-functional, I guess. So, for example, the license plates, I'm trying to remember where were the rules at for license plates. Control F, license R6. Yeah. So, for example, they showed this as a legal custom license plate here, and like this is of course the standard license plate kit. So my thing is, like, if you have your two required legal license plates, then I don't see why a team couldn't have a custom, like, non-functional decoration one. So that would mean, yes, that they have 3 on the robot, but that would still allow teams to have a decoration on their robot for, like, the license plate, or be able to be a bit more creative in that way. And so I would love to see VEX kind of clarify that and say something like that along those lines. And so while I do mostly agree with this, I think that there is some leniency in saying, okay, as long as you have your 2 legal license plates, then you can have like a third or fourth one that are non-functional. Or for example, let's say you want to print out a whole decal of your team number, and you sit there and want to plaster it on a piece of plastic that you have on the side of your robot. I think that should also be allowed, maybe not as a functional license plate, but it should definitely be allowed. Alright, so now moving on to the conclusion. With all of this in mind, we hope you have better understand why these changes were made and why we do not plan to repeal any of these updates. The GDC does not intend to hinder innovation, stifle engineering possibilities, or prevent teams from doing cool things. In fact, we feel that many of these changes encourage good engineering practices, and we look forward to seeing how teams innovate around the new constraints. If you still disagree, there's a common thought experiment that may be an apt metaphor. Sometimes you have to move backwards before you can move forwards. The GDC is committed to paying close attention to how these updates play out over the 2025-2026 season. If teams demonstrate a willingness and or capability to follow these rules as written, the GDC is open to exploring ways to slowly open some of these restrictions in future seasons. Basically, if teams don't take advantage of the rules, then we may be, or if teams don't abuse these rules restrictions, then we may lessen them in the future, which I think is fair and good for the GDC to say. However, I do think next season you will see people reference this if, for example, there is another climbing element next season, and, you know, they should bring back the 12 by 24 inch restriction. And moving on to the rest of this, we always appreciate feedback in any form, and this situation is no different. Please do not hesitate to reach out to us at gdc@vex.com with any more concerns about this topic or others. We've already received a great deal of feedback from the initial manual release, and our team is working hard on the first manual update already. And yes, we're going to fix the expansion rule, don't worry. Thank you, Vex, for clarifying that. Oh, good grief. Yeah, that's one that they definitely, in this first manual update, need to clarify, because it is currently confusing. We appreciate the passion you've displayed over the past few days. It is our hope that you are able to channel that passion into new creative ideas that will work under these new rules. Thank you and good luck to all teams in Pushback. Sincerely, the VEX Robotics Game Design Committee. Alright, so with that now said, I think that VEX is doing a good thing here by clarifying all this and telling the committee, like, hey, you know, it's not a, what's it called? Like, this isn't a punishment for years past or whatever. As far as teams, you know, using pretty much all of a 12 by 24 inch piece of plastic. But my thing is that, of course, throughout the season, you'd see teams, and I know this is for the teams that I mentored, of course, you would see teams use multiple pieces of 12 by 24 inch plastic, because they would mess up a cut or something like that, and then they'd have to cut it out of another piece, and so then it kind of is hard to tell if everything came out of the one piece. And then, of course, as they mentioned, like the really small pieces that you can't see as easily on a robot without basically taking it apart, that would be hard to do as well. So definitely respect them for just saying, hey, like, we've made up our minds and we're not going to drag this on throughout the season. As far as the ambiguity, like, this is the reason why we made this decision, and so we're hoping that you guys, of course, understand, and we'll see maybe in future seasons if we will change our mind, which is fair. And so definitely appreciate Vex for clarifying that, and definitely appreciate that they're going to clarify the expansion zone in this first update. And so, yeah. Alright, so now moving on, I think now we have our, so now what the stream is actually for, of course, being CAD, we're going to move on to that here. There of course have been some designs that I have seen on different places, different servers and things like that, on Discord, for example. So let me see where, minimize that, Discord. I have seen a couple of robots that have given me a little bit of inspiration. I'm trying to remember. Oh, and also there have been a couple of videos that I've seen of where the goals for scoring the objects in actually aren't as secure, and it's very very easy to descore this year. And so I think that actually plays to the advantages of teams with a little heavier robots. So that's another reason why I think that the restriction or the changing plastic rules aren't really that big of a deal, because it is really easy to descore. So let me pull that up actually this year. Pull that up over here. Let me see now. Mainly this was in the, what is it? I think it's, yeah, the Robolytics server. That a lot of people are in. Let me see if I can find. But basically, it showed that it was very easy. Like, all you had to do was run into the goal for the most part in order to get the blocks to fall out. Actually, here, let me see if I can. I think maybe it was 9 Motor Gang. Their video, I think. Let's see now. 9 Motor Gang VEX. Let me see. Come on now. Yeah, from a couple of days ago. So let me pause. Pull this over real quick, and we'll watch it here in just a sec. 1 second. And again, this is 9 Motor Gang if you want to check them out. Also on YouTube. So let's watch this. Yeah, they're the ones that came out with a net gun for spin up. And a few others. Why is this such poor quality? Okay, we're gonna. There we go, that's better. Yeah, this is the bot that they came up with. You can of course see how easily the game elements slide here once they're in the goals. I do like the idea of kind of trying to index the robot in a way. Let me actually lower the volume here. Yeah, and as teams have shown, it's actually really easy to descore or get blocks out of the loading zones. Yeah, it's right here mainly. Here, where was it? Yeah, so right here, 56 seconds in, you can see it. Boom. Completely full. Bot just runs into it, and like you can see where it almost pulls it up. Out of, or like pulls up the field. And then it descores all 6 and leaves the 1 right there that you could easily just pull out. Absolutely insane. So I definitely think that teams will not mind having a bit of a heavier bot if you're able to do that. However, I could see a lot of teams potentially getting in trouble for I'm trying to remember what the rule is specifically about, like when you interact with field elements. And so we may end up seeing damage done to fields or like field elements this year more than previous years, especially considering how easy it is to score by or descore by just ramming into it. Now I do know that, and I haven't really seen any talk of this yet. Let's just say that this is a robot that's sitting here in order to instead block this entire goal here that's full of blocks. Oh. So let's say that there was a robot sitting here instead in order to block all these in. You could run into the robot on the opposite side. Like, instead of trying to come to this side and ram them out, you could just come to the excuse me, sneezing. You could just ram into the robot from this side and hit them into the goal to descore it. So that's another thing of, if you have a heavier bot, you can easily do that. So that's another reason why the plastics rules changing, I don't think it's going to have a big impact on this season necessarily. So we can go ahead and finish watching this video. Well, actually, hold on, because that's playing, I'm going to pause my music over here. Yep. And another thing I think we're seeing is that it's very easy to score in both, like from a singular height, scoring in both the top and the middle there. Because you can just kind of drop it down right in front of the robot in order to score. Yeah, and here again, just boom. And getting into the parking zone is also really easy. So I forgot that they had the multiple uncut shafts blurb here. Yeah. Alright, so again, shout out to 9 Motor Gang for that one. And I'm trying to remember where that image is that I saw. I can't find it right now. But yeah, there's a few robots that I'm going to look at later to get a bit more inspiration from. Again, if you want to check out Robolytics, they're going to have a lot of ideas also in like the robot ratings channel as well. I've also seen to where it's actually not that hard to get all of the balls out of the loading zone, just in general, very quickly. You can actually do that in less than 2 seconds for all 6. Of course, that's just if you're purely trying to get all the blocks out. That's not if you actually want to intake them into your robot necessarily. However, if my design works that I have in mind, then that could potentially be the case. So that's what we'll kind of get to working on here in just a sec. Alright. So here's kind of the idea that I'm having for, see now, the main part of a robot. And I'm going to build this part first before building the rest of the robot, because when I built this chassis here, I realized that I was just trying to build a chassis, and I think this chassis can still be kind of useful. However, when moving into the, how do I put this? When considering it'll be better to have a more open back for the robot design that I have in mind, this bot is going to be a little too brickish, I guess. So I'm going to completely redesign this later, but I'm going to design it around the center contraption that I'm going to come up with here in just a sec. So now I'm going to rename this one. I'm actually going to call it the holding station. Or block holding station, maybe. Alright. So now for this block holding station, I'm going to go and quickly grab a few pieces. Let's see now. V5 parts. We're going to go structure. Let's see now. Well, I guess one thing that I should do is going back to the game manual. What is this dimension here? 3.84, right? 3.84 there. Okay, I'm going to do 4 inches just to make sure that they can fit. So, come back to here. We're going to go new part studio. Well, actually, no. Actually, I just know it needs to be 4 inches. That's the main thing that I need to know. Okay. Coming here. We're going to grab a... Do I grab a linear slide track? No, I don't think I do. I think I actually grab C channel. And then we're going to grab 1x2x1. We're going to grab... Let's see now. Let's go with a... Actually, I think I do start with a just full... A few full ones that I can then shorten later. Alright. There. And then real quick, let's go change configuration and let's change to 12.5. Okay, so from that edge. Alright. So now all these are full 17.5. So what I'm going to do first is I'm going to rotate you 90. Then I'm going to rotate you also 90 this way. Line you up here. Actually, you should probably be moved here. You should probably be moved here. You here and you here. Okay. So we're going to go you other way 90. And turn you in 90. Okay. So here's kind of the idea. Most people are going like the snail hood design, or they're going like a single kind of stack design. We're going to try and come up with a inner, and this is mainly probably going to be where plastic sheets would be used, but we're going to try and, oh, right click, I forgot. Come here, just kind of line these up. Here and here. Okay, just give a general basis for where to start from. So basically having 2 levels, one here and one here, that game elements will rest in. Now, you may be wondering, okay, well, how exactly does that work? Well, you're going to have one. These are actually going to be rotated on an angle. And that will help, of course, deliver the game elements into the goals. The idea being that you're going to have 3 or 4 game elements on top here. I'm thinking it's going to be 3 currently per level. And then potentially a couple extra, although I'll have to see. Again, this is still kind of work in progress, conceptualize for now. So let's get music started back up and let's get to building. So move on to I need like another C channel coming here. I need it to be 10 inches, we'll say. Generate. And then that needs to be, oh, nope, that is a 1x5. That is not what I need. There we go, that's what I need. So now, let's go here. Let's go here. Let's go here. And let's go here. Okay. And then all these need to, of course, turn up. 90. Oh, 95. That's 90. 90 there. And 90 here. Alright, so now all these need to turn this way 90. Ninety, 90. Oh, nope, hold up. 180. Turn it the wrong way. And then turn you 90 out. Yep, there we go. Now, to kind of set these up some. Ish here. Again, just kind of rough draft for now. We'll set you here. Ish. Now, for the cross beams going between here and here, think that, let's see now. If I go with 20 again, maybe, or I think maybe 15 might work. Yeah, I think I might go 15 again. Yeah, let's go. How about this? I'll fix you. And then let's go with 15. 1 by 2 by 1. And so this will be 7.5 inches. So I need one on this side and then one on this side. Turn you, well, don't need you moving down or up. I will turn you out though. And I'll turn you out as well for 90. Okay. So we're gonna go with planar. Check there, and then go. Not fastened. Where the heck is the... Now I'm trying to see where the mate that I'm looking for is. Okay. So you got reorients there, okay. Let's go with... Oh wait, that's the wrong one. Leave it to me to mess that up. We're going with, I guess, cylindrical or maybe Nah, it has to be cylindrical, right? Okay, yeah. Okay, so cylindrical is the axial one, so we're going to go with a cylindrical here for here to here. Alright, so now that piece can't move. Yep. Now moving with planar from here to here. Then going there to there. And then another one. We're at. I need you to be fixed as well. Okay, this top one here looks like. So cylindrical. U to there. Wait, why are you not fixed? Okay, that's weird. Should have worked, I think. So there to. Oh, I selected the wrong one, didn't I? Yeah, that's what I did. Fix. So now refix and yeah. Alright, so now oh wait. Wait, it is unfixed now. Here to kind of line up. Now, here's what I want to do here. That will be kind of oddish. Yeah, I'm trying to figure this math out real quick for the angle here. Alright, so hold up. Yeah, so 5, so 1, 2, 3, 4, 5 here. Okay, so I need to revolute you about there. So now you line up where we're at. Is it this one? No, surely not. No. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. 12, this is 13, so that should go right. Or well, 1, 2, 4, 5, 6, 7. Hold up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. I mean, that kind of closely lines up-ish. But I don't really want to try and fix it in place there. That might be what I have to do, though. Because none of these other ones are lining up at all. Yeah, I'm trying to figure this out because it is not currently lining up the way that I want it to. But okay, let's actually no. Let me just try and get the first tier done. That's the main thing that I need to do. So I'll go with... Do I actually go with a 1x1 angle maybe? No, I don't. Or maybe... Yeah, I think I go 1x1 angle on the... Okay. So we're going to go with 1x2 aluminum here. Generates. Oh. Here real quick. Here. Here. And then... We're going to go 12.5 inches, generates. Here and here. Okay. So now here and here. So now this is the... That's the connecting, I think. So then... No. You need to go that way. You need to flip this way. Yeah. Just hoping I didn't flip the wrong thing on accident. Fasten these together. And then move this kind of up to here just to... Alright. now have a better visual as far as where everything's spaced at. So I'm going to fix you in place for reference, and then I'm going to get the diagonals here. You are dimensionally how much again? From here to here, you are 0.550. Okay. So what I'm going to do then is I'm going to take my angles, 1x1 aluminum. We will shorten them to 12 point. I think I will go 15 inches. Just no, not 115. Generates here, here, and here. And then what I'm going to do is that's cut in. So I'm going to go 90 degrees in. I'm going to go all the way back over 180. And then we're going to go insert with spacers. Alright, so now where I come to here, 1, 2, 3, 4, 5, that is where it should be posted. And this is 15 here. So then this is 13. Okay, so I'm actually going to lengthen this. Figure out where, say, this spot stops. Somewhere over here. Oh? Okay, so I think I'm gonna stop it there then. So then revolute. Okay. Oh, forgot that's not fixed in place or planar to this. Let's go fast, no planar. Good boy. Try not to fall asleep right now, man. Let's see, probably there. No, that's not what I meant to select. There we go. Okay. So those are planar and will rotate with one another. I think that's a good enough slope though. Alright, so now to kind of figure out this spacing here now. Was there a trying to see if they have the game element on or like a V5 CAD model of the game element that I can use real quick. Not currently seeing an element. Oh, well, here's a. So. I see related, the field. See no CAD link though, which kind of stinks. Okay now. Yeah, no CAD link to the actual game element. Okay. So let's see now. To do I just let me hide this real quick, or let me search for a CAD element real quick, and then we'll be back in just a few minutes. Alright, now it looks like that. Actually, hold up. Yeah, okay. It looks like that there are some available on Onshape, but let me down the music a little bit more. For this, yeah, I need to go back out actually to labels, V5 parts, see now. Can I not go to this? Oh, okay. Make a copy to edit. There it is. Push back the ball. Copy document 2 owned by me. Okay. Open. I'll put this in pushback. Copy here. Okay. So, yeah, there we go. So that's going to be very helpful moving on. Now we'll go. Crap. Where'd I put the. Here we go. Now I should be able to finally insert the ball into the assembly and kind of have a better reference for. I think. Pushback ball. There we go. Four. There we go. So now, let's do, where's the furthest? I can probably close that now. From that point to that point, so we'll connect them with the VEX, or like that face. So let's go fasten here to here, flip, rotate, rotate, rotate. Huh, I thought those would actually mate together, but they don't. That's weird. I guess it doesn't really matter as much. In that case, then I'll just go connect the square faces and make this a little easier. Come on now. Oh no. Okay. There. Done. Fasten. For whatever reason, that decided to glitch out. Alright. We're just gonna move on. Okay, so now we've connected these four. It's X. 45, I guess. Yep. Now, move you down to here. Down here, and we're going to, ooh. I guess I can just make this easy, go planar mate to I guess like the fourth one here probably. No. 45 is pretty much right down the line. Okay, and here. There they go, and oh crap. Okay, so now at this angle roughly, which is I can't tell. All right. Actually, yeah, I can tell what this angle is. I just need to roughly 12 degrees. So this is 4. Of course, this is 17.5 here. So you can comfortably fit 3, I would say, in each level for what I'm thinking of. So in that case, then we're going to delete you. Yeah. Then, actually, I think you can fit 4. Let's just go here. It'll be a little more finicky, but I think it can fit. Let's go change configuration to .5-inch. Change configuration. 12.5-inch. And this gets limited now to actually what? Losing my mind. 5, 10, 15. Right? Five, 10, 15, 22. So 11 inches. All right. So coming off of this, the reason that I think this could work potentially is because you do have a little bit of space here at the back also. And again, this is just me kind of throwing 4 in here, but you could of course have rubber bands out the back here, or not even rubber bands necessarily, but like, and I've seen teams kind of have this already on their robots, but a little latch sort of mechanism. So let me here. Copy 6 items. And then, actually, hold up. Let's go 1, 2, 3, 4, 5, 6, 8, 9, 10. We're going to do paste all 10 items. And now we're going to go here with this entire thing. Whoa. Oh, crud. There we go. Now that's more where I'm looking at. Let's come slam this down as close as we can. I think right there's it. Okay, now. So in order to complete this, I need why did that zoom out just now? Right here. Ah, crap. And then fasten. Not planar. Parallel. There we go. Alright, so lengthwise, just on bot currently, this is 12.5 inches. Yeah, 12.5 inches. So, Okay. And then like this is the only cross beam that's currently required. Okay, there's some changes already I can see that I would make, but we're gonna kind of keep it like this for now. Yeah, and then this will lower down, and that's how far up off the ground? 4 inches. To this edge, that's how tall? For the Z direction, that's 2.843, so we'll just say 2 5/8 roughly to clear there. So we're gonna go the new part studio, and then we're gonna go I think we're gonna sketch front plane, and we're gonna go there. Now this needs to be I'm gonna say 5.5-ish. Oh wait, I forgot. This is unfixed. Actually, hold on, let me measure what's the inside face to inside face right now. 4.416. I think that'll just make that 4. Offset in the Z's. Inches. Oh, wrong way. Solve. Okay. Oh, that is. Did I read it wrong? I had to have. That sounds about right. It's 4.5 inches. Was it 4.5 maybe that I saw? Solve. Yeah, 4.5. Okay. That looks about right-ish. Yeah, a little bit of wiggle room. It'll still flow down. They slide easily. So yeah, so 4.5 there. Then I need to make this what, 5.5 inches wide. .6, I'll make it 5.5. Where's dimension? Wait, nope, that's in sketching. Construction, so here we go. 5.5 inches by, we'll say, I know it's not 2.5, but I gotta count real quick again to see. I mean, it basically is 2.5, so I guess I could just leave it. And so then say okay, extrude this 0.07 inch Alright, so now this will be used for sheet model, corner break, part 1. Export. Not parasolid as. I want to do a step format, and then we're gonna do block holding station. Actually, yeah, I'll do poly sheet 1. Actually, cancel. Rename. Okay, so wait, can you sketch other stuff in the same part studio? I'm not actually fiddling around with. Okay, so that's part 2. Okay. Gotcha. Okay. Anyways, I'm gonna come back over here. We're gonna go insert, current documents, play sheet 1 here, click. Then, so we're just gonna do a planar here to here, then which one's lower? They're the same. Okay. Yeah, kind of figure out 0.011, 0.089. Actually, I can probably just edit. Make this 5.6 inches. Ow, my ear. Yeah, so that can stay there. Okay. Now, here we go. So yeah, currently this is what the robot will look like. Then I think go with trying to think through this real quick. or at least the center of the robot, I guess, for the storage mechanism, and can actually make these two shorter. Change configuration to 10 inches instead. Lower you just a little bit. Oh yeah, perfect. Maybe even lower it more. And potentially even like if you're able to decrease this angle, lower it a little more. Alright. So basically, the idea is to have an intake out here that will bring the balls or the blocks up and into this storage bay, and then this storage bay can then be elevated in order to score into the different goals. So then that would allow you to have 8 that you could rightly score, plus 1 or 2 in the intake out here, depending on how you build the intake and how it's deployed. And so I think having this built now, I think I'm going to leave it here, think a bit more on this, figure out how I want to get the intake plus the feed up, like to get the balls up to this height system completed, as well as the, well, there's already been teams show like their latches for holding the balls back, and so I don't think that's going to be as hard to figure out. But yeah, so I think that's where I'll leave this stream off for now. Yeah, so thank you for watching. If you have, please consider subscribing to our channel and following us this season in VEXU Pushback. And I will come back later in order to do some more on this robot. Probably not tomorrow, but sometime hopefully this weekend. Alright, thank you.